Guys, the next thing we're going to look at are the properties of polygons. This is on page 69 of your workbook. Now, a polygon is just a closed shape that is made up of 3 or more lines. Let's look at some examples of polygons. Three-sided shape that we are all familiar with, called a triangle. That's also a polygon. A four-sided shape, so it's made up of 4 different line segments joined together. That's called a quadrilateral. A 12-sided shape is called a dodecagon. Let's look at the diagonals of a polygon. In a quadrilateral, which is your 4-sided shape, you have 2 sets of diagonals. Remember, diagonal is drawn from the vertex of one side to the vertex of the opposite side. So in a quadrilateral, so it's a 4-sided shape, you get 2 diagonals. In a pentagon, which is a 5-sided shape, we get 5 diagonals. So once again, drawn from each vertex to the opposite vertex, you can draw that 5 times. And in a hexagon, which has 6 sides, we get 9 diagonals. So that means it's possible to go from vertex to vertex 9 times. Guys, it is possible to work out the number of diagonals that a polygon will have using this following formula. Your number of diagonals is equal to, and this is for any n-sided polygon. So your number of diagonals is equal to a half times n minus 3, where n represents the sides of your polygon. So for example, the one that's very easy and that we all know, the quadrilateral with 4 sides, so here n is equal to 4. If I would like to know how many diagonals in the quadrilateral, all I do is I say it's a half times the number of sides, which is 4, times 4 minus 3. And this will give me 4 times a half is 2, 4 minus 3 is 1. So therefore a quadrilateral, which we saw in the beginning, will have 2 diagonals. And that's the formula that you can use in order to work out the number of diagonals in a polygon. Guys, the next 2 properties that I'm going to look at of polygons are not in your workbook, but these are important properties that you also need to be aware of. The first thing we'll look at is the sum of the interior angles of a polygon. Now for this, you can use a special formula to work this out. So for any polygon with n sides, the formula to work out the sum of the interior angles is given by 180 degrees times n minus 2. So once again, if we work with our easy example of a quadrilateral, we already know, hopefully you all realize and remember from the previous parts, that the sum of the interior angles of a quadrilateral are 360 degrees, but we can work it out using this formula. So a quadrilateral, remember, is a 4-sided shape. N represents the number of sides. So therefore the sum of the interior angles would be 180 times 4 minus 2, using my formula. So it would be 180 times 2, which is equal to 360 degrees. Okay, which we know is correct because we are all familiar with a quadrilateral. The next thing we're going to look at is how to determine the size of an interior angle of a regular polygon. Now, a regular polygon is a polygon where all sides and all angles are equal. So this is for a regular polygon, and this is to work out the interior angle. So what is the size of just one of the angles? The formula we use here, remember, where we're working with a regular polygon of n sides. To work out the size of one angle, we say 180 degrees times n minus 2 all over n. So if we look at a regular hexagon, remember a hexagon has 6 sides, so each of these sides being equal, and each of the angles, if we just call them all x, they are all equal to each other. If I would like to determine what the size of each of these angles are, all I've got to do is substitute it into my formula to work that out. So it's 180 times n, which we know is 6 since we're dealing with a hexagon, minus 2, all over n, which once again is 6. So I get 180 times 4 all over 6. 180 times 4 is 720, divided by 6, and that will give me an answer of 120 degrees. So therefore what that means is that each of these angles will have a value of 120 degrees. So guys, we've looked at some of the properties of polygons that you need to be familiar with. You also need to know how to use the formulae to help you to work out the number of diagonals, the total sum of the interior angles, and the size of each interior angle. So that concludes this lesson on geometry. While there weren't many new concepts introduced to you, the concepts that we did cover are very important, and if you continue with geometry, you will need to refer back to these over and over again.